This is a vertical mill. What does a vertical mill make? Just about everything that starts out as a square block of raw material. You think about your iPhone or your Android device. The metal part of that is made on a mill. All right, the rims of your vehicle are made on a mill. The molds that plastic and rubber are shot into are made on mills. Think about the bottoms of your shoes, the dashboard of your car. All right, we use all kinds of stuff. The most important thing to know about running this mill is how to shut it off. If you get into trouble, and all my usual teachers will have once you get in trouble on here, he saved his finger by hitting that off button. All right, so you got to know how to shut it off as fast as you can. So the E-stop button is right here. Your on-off switch are in the back. Flip the lever up like this. That'll turn the machine on. These are a CNC machine. They're conversationally controlled. We're not going to use them as CNC machines in here because unfortunately they're so old. They're late 80s machines. The computers are starting to go on a couple of them. And I can't teach half the class how to run CNC and half the class how to do manual. So we're just going to do all manual, which is just fun. If you go to WITC for machine tool, the whole first year is on a manual mill and a manual lathe. Right? So, on our machine here, a couple things. We've got our bed right here. This is our bed or our table. This goes on the x-axis, left and right, y-axis, front, back, and our z-axis, up and down. The z-axis is controlled with this handle right here. Crank it in there, crank it up, crank it down. All right? They call this the knee, because if you leave it like this all the time, you hit your knee on it and it hurts. So when you're done adjusting, you make sure you always turn it around like that. Our y-axis goes in and out here. Our x-axis gets moved right over here. Notice too, on all of these handles we have for moving these, there's dials on here. These dials are how we're going to measure and how we do things accurately. These are all in thousandths of an inch. They're decimal format. Alright, so like on this handle right here, one full revolution on this is 0.2. We go one full revolution on it, 0.2 or a little bit under a quarter of an inch. And that's when we start talking about decimals in decimal places in the classroom, so you get used to that. On here's our vise. It's the best way to hold things in place on the mill in our shops, using our vise on here. Up here we have our controls for turning our spindle on. This is our spindle right here. Turn it to high gear always. High gear spins it clockwise. If you spin it counterclockwise in low gear, you're going to wreck our bits. And some of our bits are $60, some of our bits are $100. We've got one bit that was donated at $600 for one bit. So you've got to be cautious of what you're doing. To put a bit in, we got a whole set of collets back here. This is a collet right here. There's different size collets. This is a 5/8 diameter collet. This is a 5/8 diameter end mill. And this is what you call a two-flute end mill. There's two cutters on it. You can take this end mill, slide it in the collet like this. All right? If you notice on here, there's a keyway. This keyway needs to get lined up with the key inside of here. So I'm going to feel for that keyway. I'll line it up. I can slide my bit in there. I'm going to move this back now. It's out of the way. Slide it on up in there, and then I can push in this green button here and hit in. And I'll suck my bit in there and hold it in place. You're going to take your bit out, push it on the green button, hit out. Hold on to it. Don't just let it drop. Again, these range in price from $40 to $60 to $80. If you just let it drop, you can chip it out. I'll put that back in there so it's ready to go. Putting your workpiece in the vise. On the back of each machine, there's a set of what we call parallels. You never take your part and just set it in the bottom of the vise and cut it out like this. It's not going to work. Your bit's going to hit the vise. We want to raise this thing up like this so we can actually work on it. And so we use precision ground parallels for that. Here's a mostly full set of them. Alright? Range from 1.5 inches all the way down. These are like 3/8 of an inch. Just guessing by looking at this, you know, 1.25 inches might work pretty good. I'll put my parallels in there like this. Set my part in there. Actually need to go a little bit higher. You want it sticking above the vise. There's a fine line between above the vise and too high. You got to make sure you got enough gravity on your part so it doesn't throw the part when you go to cut it. Here's our handle here. I'll bring this thing in. And now I just need to snug it down. You don't need a reef on this thing and give it a ton of pressure to hold it in place. These are really good vices. Now my part's in there. Now look at this. See my parallel? No good. I squeeze that vise on and move my piece a little bit, right? So what you got to do is take a dead blow hammer, which are these toolboxes. Each toolbox is set up with a set of tools for each machine. So you got to see this is a dead blow hammer. You hear that in there? What's inside of a dead blow hammer? Anybody know? There's little PVs, a little shot. And what that does when you hit down on something nice and gently, the hammer doesn't bounce back. It's a positive hit, then it moves the object down. If I take this and just tap on it, lightly, now my parallels are set and I'm good to go. Notice I'm not over there wheeling on it like I'm chopping firewood. There's no need to do that. Alright? Now I'm ready to make a cut if I want to. I can turn this on to high gear, hit this button here, it's spinning, or it's in the vise. A couple decisions you've got to make. Your spindle speed. There's a formula for that. Believe it or not, you can use math here quite a bit. But there's a certain speed you spin the bit. If you spin it too fast, you're going to burn it up. If you spin it too low, you're going to wreck the part. Alright, we're using a 2-flute end mill in aluminum. I know we're pretty safe at like 800 RPMs from my experience. So I'm going to have some bits ready for you so you don't have to do that math. I'll just tell you, hey, this is 600 RPMs, this is 800 RPMs, go. Right? So your spindle speed is important and your feed rate is important. How fast I'm running it through there. When I bring that bit up, we can make a cut. Crank this thing up. And that pops out there once in a while. And I'll bring it over. What I'm going to do is I'm going to turn my spindle on. I'm going to slowly bring it up and touch off. Touching off means I'm going to barely nick the top surface of the part. Just like that. See that? Now I'm going to move my bit off the part. Move over a little bit. At this point, I can set my dial over here to 0. So if you look on here, make sure you can see this. I can loosen up the knurled one here like this. I can rotate my 0 over to that little notch in here, right? And I can tighten this back down just like that. So 0 is the top surface of my part. Now that I'm off the part, I can crank this up to say 20 thousandths of an inch, 0.020. Now I can make a cut. I can crank it across. This is my feed rate that we're talking about. Should I be over here going like this? No, you're going to wreck your bit, wreck your part. Nice gentle feed rate. What am I looking for to know that I'm doing things right? I'm looking at the chips coming off the part. I've got nice curled chips coming off there. They're pretty decent in size. I got a decent surface finish. It's not real rough on there or anything like that. And there we go. If your chips come off and they're like a real fine powder, something's not right. If you see sparks flying, something's not right. You need to stop and ask yourself, what the heck is going on? Okay? When you're done with the machine for the day, it's important to take your bits back out, take your parts out. You can take your parts and set them in the toolbox. It's a good place to store them. Just maybe write your name on it with a Sharpie or something so you'll get mixed up with somebody else's. And then sweep the machines down and also mount the vacuum on the wall with a vacuum motor. Saves a little bit of time with that. Alright? Long sleeves. Roll them up. Right? Strings tuck them back. Jewelry tuck them in. You got to be cautious. Gloves, never wear gloves on here. Other than that, I think we've got pretty much everything covered. Any questions on the mill? Okay. Send the next group out.